So we almost have all the pieces worked out now. The only one we're still missing, well, there's two we're still missing. We're missing this phi here, and there's also that plus b on the end. But that's the easy one. It's just an up-down shift. So we're actually going to get to that one right at the end here. What that phi represents, if you think back to your pre-calc or college algebra class, it's a vertical shift, right? It moves the graph side to side. And that's all it's going to do here. We just have a special name for it. When you're talking about trig functions, it's called the phase shift. So let's see how this works. Let's start out with a basic example, right? Y equals cosine x plus pi. So, and I really want to think of this in terms of a vertical shift. So let's start by graphing y equals the cosine of x. So it's going to start at 0, comma pi, and it's going to end over here. Its first period is going to end at, that's 0, comma 1. It's going to end at 2 pi, comma 1. The minimum is right in between the two, so that's going to be at pi, comma negative 1. Let's get some more than just one period so we can see how it moves around. So let's see. The minimum over here, the next minimum will be at negative pi, comma negative 1, and the next maximum will be here at negative 2 pi, comma 1. All right, so now we can sketch in the graph real quick, right? We've done this before. I'm gonna come up and down and up. Not bad. That was a close call, but we'll fudge that a little bit. And down. Okay, now let's do the graph that we want. We're looking for y equals cosine of x plus pi, and that x plus pi means the phase shift is pi units to the left. So let's see what that does. I'm literally going to take these maximum minimum values and just shift them and then use them as guideposts, if you will, right, to sketch my new graph. So the point that was at 2 pi, comma 1 gets moved pi units to the left. So now it's at pi, comma 1. This point that was at pi, comma negative 1 gets moved pi units to the left. Now it's at 0, comma negative 1. This point up here gets moved to negative pi, comma 1. And this point down here gets moved to negative 2 pi, comma negative 1. And, well, let's get one more here, right? If there's a minimum here at 0, negative 1, then there's the next minimum to the right will be here at 2 pi, comma negative 1. Let's see, what did I say? This is 2 pi, comma negative 1. And that's enough. Now I can sketch the graph. It starts down here, comes up and down, up and down and up again. And there's my graph, my phase shifted graph. All right, now there is a trick to these phase shifts a little bit. I hate to say trick. There are no tricks in math, right? But there are subtleties. There are things you've got to be careful of. So looking at this one here, you might be tempted to think that the phase shift was pi, but it isn't. All right, when we're talking about vertical shifts, it's a number that's being added or subtracted from the x, not from 2x. Right, so that 2 out in front is a problem. But I can fix this easily enough. I'm just going to factor out a 2. So this becomes y equals cosine 2 times x plus pi over 2. All right, now this I can graph, right? So, but we're starting to get more pieces here. So let's try to stay organized about this. This thing has a phase shift of pi over 2 to the left, and its period is 2 pi divided by 2, which is pi. All right, so let's graph this one, right? Sorry, let's start off. Just do the period part. So I'm going to start by graphing y equals the cosine of 2x. I'm going to start at 0, 1, and then I'm going to get back there 1 period later. So that's going to be pi units. So I'm there again at pi, 1. And my minimum value is right in the middle of those two. That's pi over 2, negative 1. All right, now again, let's get a little more in here. If I go over to negative pi, 1, that's going to be the next maximum, and the next minimum will be here at negative pi over 2, negative 1. And that should be enough. And that should be enough to give me a good idea of what this thing is going to look like. So I'm going to start here, come up and down and up, trying really hard to hit my marks. There we go, and down again. Okay, good. Ooh, well, fair. Okay, now let's do the next part. Let's get the graph we want. Y equals cosine 2x plus pi over 2. So I'm going to take this graph, and I'm going to focus on those key points, those maximum and minimum values, and shift them. All right, so this first one, pi, 1, if I move that pi over 2 units to the left, it ends up at pi over 2, 1. This minimum moves over to 0, negative 1. This maximum goes to negative pi over 2, 1. The next minimum goes to pi, negative 1. And this maximum up here, if I go over pi or minus pi, let me write it, minus pi over 2, that's going to be minus 3 pi over 2. That's 9, 3 pi, that's 9 divided by 2, so that's about 4.5. 1, 2, 3, 4. And my scale is a little off. Let's put it right there. Okay, and now I can sketch this thing. This is this one that was probably a little off. Let me scoot that one over a little. Let me try to make it a little more symmetric. So I'm going to go down and up and down and up and down and up, right? And there we go. All right, so that is going to be my graph. Y equals cosine 2x plus pi. Right, and you can kind of see what's happening here. Let's check this real quick. See how good my graph is. Because it looks like they both have intercepts at the same spot. Right. So what is this spot? This spot here is going to be halfway between pi over 2 and pi. So that's going to be 3 pi over 4. All right. So let's put that into both of these. Let's do this one first. Y equals cosine 2 times 3 pi over 4. That's the cosine of 3 pi over 2, which is 0. Good. And if I put it in here, what do I get? This is y equals cosine 2 times 3 pi over 4 plus pi. That's cosine 3 pi over 2 plus 2 pi over 2. That's the cosine of 5 pi over 2, which is 0. Yeah, that is how it's working out. It's always nice when we can do a little confirmation, right? Okay, so there you go. There's the graph of this function. All right, so let me give you one here. See if you can't do a practice run with this one real quick. See what you come up with. All right, so again, that minus 2 is a little bit of a problem. I'm going to factor that out. Sine minus 2 x minus pi. And now look, with my sine function, I'm going to use my sine negative angle identity. I'm going to bring that negative in front of the minus 2 out in front. This is minus sine 2 x minus pi. So now I have three things going on here. I have a phase shift that is pi units to the right. My period is going to be 2 pi divided by 2, which is pi, and I have that minus sign. Right, that minus sign is a reflection across the x axis. So I got three things I got to build in here. Okay, so first, let's do that period. All right, so I'm going to start by graphing y equals, so we're doing sine now, sine of 2x. Okay, so the sine function starts at 0. It's 0 again at pi, and it's 0 again at pi over at 2 pi. And my maximum, so let's see, my maximum value is in the middle. Whoops, I'm sorry. I was doing 2 pi again. My period here is pi. So I'm going to start at 0. Then I'm going to go over pi. And that's where it's going to be at 0 again. All right, so that is 0 or pi comma 0. And 0 comma 0. And its other intercept is halfway in between them. So it's going to be about here, right? That's I don't want. I try not to write too much in here because we're going to put all these graphs in there. This is pi over 2 comma 0. And then where are the maximum and minimum values? Because those are the ones that I really like to track on. It's going to be halfway in here. So this is going to be pi over 4 comma 1. And then it's going to be down here. This will be 3 pi over 4 comma negative 1. Okay, now let's get, I like to do more than one period, so let's do these again. If I go out to 2 pi comma 0, halfway in between these two is this middle x-intercept. So that's going to be, let's see, what am I in the middle of here, right? This is between pi and 2 pi. So this is 3 pi over 2 comma 0. Okay, so where's my maximum then? Well, it's going to be right here, right? And this has a period of pi, right? So if this one is at pi over 4, then the next one is going to be pi units over. So this one is 5 pi over 4 comma 1. And the minimum will be here at 7 pi over 4 comma negative 1. Okay, now I'm just gonna clean this up, right? Because really I'm gonna take out all of my notes about the intercepts. Because what I really like to track on is those maximum and minimum values. So now I'm gonna sketch my curve here. Okay, now let's start making adjustments. Okay, next one. Now let's do the phase shift. Y equals sine 2x minus pi. So I'm going to take every point and move it pi units to the right. Okay, probably should have done some more points to the left, but that's okay. Let's see what we come up with. If I take this point pi over 4 and move it pi units to the left, it ends up here at 5 pi over 4. And if I take this point at 3 pi over 4 and move it 5 units to the left, it ends up here at 7 pi over 4. Okay, well, this is kind of weird, right? Let's see. Now I really am getting curious. Let's do some more here. The next minimum is here at negative pi over 4, comma negative 1. And if I shift that pi units to the right, where do I end up? Well, it's going to be here. 3 pi over 4. Okay. Well, that's interesting, but I'll take it, right? This green graph is actually the same as the red graph, right? So what happened? Well, look, let's think about this for a minute. What did I do? I shifted it one period to the right. Well, yeah, okay. I mean, if you shift a graph one period in either direction, yeah, it should be overlapping itself again. All right, so now we have just one more thing to do. We got to do the minus sign. Y equals minus sine 2x minus pi. And that's just going to flip it, right? Every point that is a maximum becomes a minimum. Every point that is a minimum becomes a maximum. And I'm going to sketch through those points. And there is our graph. Now let's see if I can clean this up a little bit, just so you can see the finished product. Let's see if I can take out a lot of this green and red, and we'll be left with just, there you go, just our final graph, right? That's where we end up. Okay, so I got one more thing to add here, and we will have everything, right? You notice I tacked this 1 here on the end. All right, so let's see, what does that 1 do? Well, okay, I graphed the sine of 2y equals sine of 2x minus pi, right? That's the one we did on the last slide. And we saw that this is the same as y equals the sine of 2x. All right, so let's graph that real quick. Let's get it back on here. It's got root. We're going to start at 0, right? And we're looking at pi for the period. So that's pi comma 0. So then let's see, pi over 2 is where the other root is, and the maximum and minimum are in between them. So here at pi over 4 is where the first maximum would be, and here at 3 pi over 4 is where the minimum would be. All right, and again, let's get a little more in here. I'm going to go over here. This is negative pi over 4, comma negative 1. And then let's see, if I go pi units over from that, I'm going to be at negative 5 pi over 4. And that's where the next maximum is going to be. All right, now, I'm not going to graph this. Let's go ahead and do the 3, because the 3 is pretty easy. Y equals 3 sine 2x minus 2 pi. That 3 triples everything, right? So the points that were at 1 are now at 9. And the points that were at negative 1 are now at negative 9. Okay. And, well, let's see. Let's keep track of, I want to keep track of where these roots are. Right, they're here and here. And another one there. Because now, think about what happens next, right? I'm actually kind of doing everything at once, aren't I? Now, let me make that different. Now, let's do the plus 1. What does that plus 1 do? Well, it moves every point up 1. So this goes from 9 to 10. This goes from 9 to 10. This goes from 0 to 1, right? All the intercepts move up 1. And these points, the minimum values, move up 1. And now I'm going to very carefully make sure I don't miss one, because this is a very steep graph. Don't hit the don't hit, it's not the next intercept anymore, right? Then I'm going to come down and up, right? And there's my graph, right? This is the kind of the full-on example, right? We've got everything going on here. We have the amplitude is 3. Let me write it all out here for us, just to summarize. The amplitude is 3. The phase shift was pi to the right. The period was 2 pi divided by 2, which is pi. And finally, we have this up 1 shift. So at this point, we've covered all of the different components of a trigonometric function and how they impact the graph. So what we have left to do is to talk about the other 4 functions, right? So we're squared away on the sine and cosine. In the next in the next lecture, we're going to look at secant and cosecant, and then in the lecture after that, we'll do tangent and cotangent. While the shapes of those graphs are different from the sine and cosine, their behaviors are the same. They're going to be made up of the same components, and the components are going to have exactly the same impact on the graphs.